हेलो स्टूडेंट्स, सो टेस्ट 74 का डिस्कशन स्टार्ट करते हैं. इट्स अ डिफिकल्ट पेपर. ओवरऑल पेपर डिफिकल्ट साइड पे है. आई विल से 135 to 140 इज अ गुड स्कोर. 12 क्वेश्चंस डिफिकल्ट क्वेश्चंस की कैटेगरी में मैंने रखे हैं और 12 मॉडरेटली डिफिकल्ट की कैटेगरी में रखे हैं. 21 क्वेश्चंस ईजी कैटेगरी में हैं. सो लेट्स स्टार्ट फ्रॉम क्वेश्चन 1. Titanium with a half-life of this undergoes beta decay. What fraction of sample of pure tritium will remain undecayed after 25 years? So two half-lives. So after two half-lives, n is n naught by 4. So remains undecayed. So 1/4 remains undecayed. So n naught by 4. So B is the correct option. An electron makes a transition from an excited state to the ground state of hydrogen-like atom. Then Ke. So we know kinetic energy is minus k ze square by plus k ze square by 2r. So as r decreases, kinetic energy increases. Potential energy is minus k ze square by r. So as r decreases, value increases in negative, so u decreases. Similarly, for total energy, minus k ze square by 2r. So as r decreases, number becomes more negative, so total energy also decreases. So K increases and potential energy and total energy decrease. Next, a curved rod of radius, the diameter this is banked so that friction is required. No friction is required. That means this is banking speed. So tan theta is v square by rg. V square by rg. So v is 30. So 30 into 30. R is 0.9 kilometer. That means 900 meter. And g is 10. So this is 0.1. So theta is tan inverse 0.1. The linear momentum is this. Then the force is dp by dt. So since linear momentum is varying in quadratic manner, so force dp by dt is b plus 2 ct. So it changes linearly. So force is time dependent. This is the correct option. Two buses A and B are moving around concentric circular paths. If they complete the circular paths at the same time, so they cover in same time, that means their time period is same. So omega is also same. Omega A is equal to omega B. Now radius, so speed is omega R, so proportional to R. So VA upon VB is RA upon RB. So straightforward question hai. Flywheel rotates about a fixed axis, slows down this to this, then it's angular acceleration. So alpha is omega final minus omega initial upon time t. So that is 100 minus 300 rotation per minute. So 2 pi radian per minute upon 2. So that is minus 200. So minus 300, 200. So 200, 2 cancel. So this is minus 200 pi. So retardation is 200 pi. Silver wire has a temperature coefficient of this and its resistance at this, then at then due to neglecting any change in dimension due to change in temperature, its resistance in 40 degree. So R2 is R1 1 plus alpha T2 minus T1. So R1 is 10 ohm and 1 plus alpha 4 into 10 to the power minus 3. T2 minus T1 is 20. So that is 10 into 1 plus 80. So 0.08, which is 10 into 1.08. That is 10.8 ohm. So straightforward question here. The resistance R1 upon R2. So R is rho L by A. Both are from same metal sheet. So proportional to L upon A. So now RA upon RB. Length ratio is 1:2 and area ratio. See, area is LT and 2LT. So area ratio is also 1:2. So that is 1:1. So RA upon RB is 1:1. Circular disc of radius this is placed in uniform magnetic field in such a way that its axis makes an angle of 60 degree with the magnetic field. So axis area vector is along the axis. So area vector is at an angle of 60 degree with magnetic field. So flux length is B pi r square into cos 60 degree. So B is given 1 by pi into pi r square 0.04 into cos 60 1 by 2. So that is 0.02 Weber. This is the flux. Straightforward question. In an AC circuit, E is this, I is this, then the average power consumed. So average power consumed is P average is Vrms, which is Vm by root 2, Irms, which is Im by root 2 into cos phi. So that is 200 into 2 upon 2, cos phi is half. So 400 upon 4, that is 100 watt. A charge Q is uniformly distributed over the surface of two concentric conducting spheres of radii capital R and small r. So uniformly distributed, that means the surface charge density is same on both. So surface charge density is sigma is Q upon total area, which is 4 pi capital R square plus small r square. Now we have two concentric conducting spheres. So potential at the center. So potential at the center due to the sphere 1 is K Q1 upon R, and potential at the center to the sphere 2 is K Q2 upon capital R. So K Q1 is sigma into 4 pi R square by R, and Q2 is sigma into 4 pi capital R square upon capital R. So this is sigma K and 4 pi small r plus capital R. Now sigma is Q upon 4 pi capital R square plus small r square into K into 4 pi small r plus capital R. So this is Q into small r plus capital R, K Q into small r plus capital R upon capital R square plus small r square. So K Q is capital R plus small r upon small r square plus capital R square. B is the correct option. IIT में आया हुआ है पहले क्वेश्चन. Two identical capacitors with like polarities together, negative ends together and positive ends together, the decrease in energy of the combined system. So we have standard formula. Loss is C1 C2 upon 2 C1 plus C2 V1 minus V2 का square. So that is C by 4 V1 minus V2 का square. So C is the correct option. A body of mass m is placed on Earth's surface. It is taken from the Earth's surface to height 3r. That means from center 4r. The change in gravitational potential energy. So change in potential energy is minus gmm by 4r. This is the final energy, and initial energy on the Earth's surface. So minus gmm by capital R. So this is gmm by capital R 1 minus 1 by 4. So that is 3 by 4 gmm upon capital R. Now G capital M can be written as small g r square into small m. So that is 3 by 4 mg r. So B is the correct option. Two planets have same average density, radii in the ratio this, then the ratio of G. So in terms of density and radius, G is 4 by 3 pi rho G capital R, so proportional to capital R. So G upon GB is RA upon RB, which is 3:1. So A is the correct option. Three rods, they are arranged. So heat coming from 100 degrees Celsius is going into this H2 and H3. So in steady state, H1 is equal to H2 plus H3. Now H1 is K, which is 3K A 100 minus T upon L. H2, which is 2K A T minus 50 upon L, and H3, which is Ka T minus 0 upon L. So this is 300 minus 3T equals 2T minus 100 plus T. So that is 60 equals 400. So T equals 200 by 3 degrees Celsius. So A is the correct option. Gas expands according to this. Calculate work done when the temperature changes by this. So V is K T to the power 2 by 3. So dV by dt is 2 by 3 K T to the power minus 1 by 3. Okay. Now work done is P dV integration. P is RT by V. Number of moles we are assuming 1 since it is not given. So RT by V. So RT by V dV. Okay. So now RT by V, and V is K T to the power 2 by 3. So RT and V is k t to the power 2 by 3. This is v, and dv is 2 by 3 k t to the power minus 1 by 3 dt. ये ऊपर से सब्स्टिट्यूट किया अपन ने. सो सी t to power 2 by 3 into t to power minus 1 by 3 into t, this cancels out. So and k cancel out. So this is 2 by 3 r dt integration from temperature change by 60 Kelvin. So this is 2 by 3 r T2 minus T1. So that is 2 by 3 r into 60, that is 40 r. So work done by the gas is 40 r. So I advise to leave this question. I mean, during the exam you should have left this question. It's quite demanding in calculation. A, B, C, A. See, concentrate upon the graph. First we should always concentrate upon the x and y parameters. So y is volume and x is pressure. So it is VP diagram, है ना? It's a V versus P diagram. V is on vertical axis and P is on horizontal axis. So A, B, C, A, if the net heat supplied, that means the total work is given is 5 joule. So W from A to B plus W from B to C plus W from C to A is the total work, which is equal to total heat. Now W from A to B is isobaric process because pressure is constant. So A to B, so pressure is 10 and volume change 2 minus 1. So this is WAB. WBC constant volume, so this is 0, and WCA is to be found out. Q is given, the heat supplied to the gas in the cycle is 5 joule. So this is 5. So WC2A is minus 5 joule. So answer is A, minus 5 joule. 1 mole of an ideal gas expands according to the law. So if the final temperature is 2 T naught, heat supplied. So this is polytropic process. We know heat capacity is CV plus R upon 1 minus X. So this is 3R by 2. Gas equation is given. V to the power minus 1 is equal to constant. So this means X is minus 1. So 3R by 2 plus R 1 minus 1. So that is 2R. So molar heat capacity is 2R. Now the final temperature is changed from T naught to 2 T naught. So heat supplied is NC delta T. That is N. C is 2R. And delta T is 2 T naught minus T naught, which is T naught. Number of moles is 1. So this is 2R T naught. Okay. 3 ions having charge plus E plus E plus 2E have the same kinetic energy and same magnetic field perpendicularly. Then who will deflect least? So lesser is the radius, greater is the deflection. Okay, see, like एक पार्टिकल कम रेडियस में घूम रहा है और एक पार्टिकल सपोज यहीं से स्टार्ट हुआ और ज़्यादा रेडियस में घूम रहा है, तो डिफ्लेक्शन किसका कम ज़्यादा हुआ है? डिफ्लेक्शन ज़्यादा हुआ है जिसकी रेडियस कम है. द पार्टिकल विथ स्मॉलर रेडियाई विल डिफ्लेक्ट मोर फ्रॉम इट्स इनिशियल डायरेक्शन ऑफ मोशन. सो लेट्स कंपेयर द रेडियाई. सो आर इज mv by qb, that is root 2 km by qb. Kinetic energy is same, so proportional to under root m by q. So RH plus is to R helium plus is to R O plus 2 is mass ratio 1 is to helium under root 4 is to oxygen under root 16. Charge ratio 1, 1 and 2. So this is 1 is to 2 is to 2. So least radii is of hydrogen, so it will deflect the most. And helium plus 2 and oxygen plus 2 have same radius, so they'll deflect by equally. They'll deflect equally, so B is the correct option. Bar magnet length this, cross-sectional area this, magnetic moment this, the intensity of magnetization. So intensity of magnetization is magnetic moment upon volume. So that is 3 ampere meter square and volume is 6 into 10 to power minus 6. So that is 5 into 10 to power 5 ampere per meter. So D is the correct option. Maximum instantaneous velocity. So V is dx by dt, that is slope of ST graph. So we see graph is steepest around C. At C, the slope is highest. So around C, the instantaneous velocity will be maximum. Bomb is dropped from an aeroplane flying horizontally with a speed of this at an altitude of this. The bomb will hit the ground. So the initial velocity uy is 0, ay is g downwards, and delta y is h. So from second equation, delta y is uyt plus half ayt square. So t is under root 2h by g. So that is 2 980 upon 9.8. So that is 10 root 2 seconds. Block of mass m is on a rough horizontal surface. Coefficient of static friction is this. Acceleration of truck is this. Find the frictional force. So frictional force provides a required acceleration. So is equal to ma. That is 1 into 5, which is 5 Newton. Now check whether this is possible. So Fs max is mu s n, which is mu s mg, which is 6 Newton. So since requirement of friction is less than Fs max, so this situation is possible. We'll say friction is 5 Newton only. Had this friction been greater than Fs max, then the particle will start slipping, and we'll say that friction is kinetic, whatever the kinetic friction. The minimum mass of C that may be placed on A to prevent it from moving. So the driving force for this entire arrangement is mbg, and friction is trying to hold the system at rest. So in limiting equilibrium, mbg is equal to mu s ma plus mcg. Normal reaction is ma plus mcg. So mu s ma plus mcg. So we want to find mc. So mc is mbg. Mgg cancels. So mb is 5, mu s 0.2, ma is 10 plus mc. So that is 25 minus 10, 15. So mc is 15 kg. 5 upon 0.2, 50 upon 2, 25, 25 minus 10, that is 15 kg. So minimum mass required is 15 kg. Sample contains a large number of nuclei. The probability that a nucleus in the sample will decay after 4 lives. Okay, so number of nuclei decayed within 4 half-lives, is n naught minus n naught by 16, that is 15 n naught by 16. Okay, so the probability of decaying within first 4 half-lives is decayed upon possible decay, which is 15 by 16. Okay, so a nuclei, so probability of decaying after 4 half-lives is 1 minus 15 by 16, that is 1 by 16. So according to me, answer should be 1 by 16. 0.2 ml sample of solution containing this curie is injected into the bloodstream. Okay, after sufficient time for circulatory equilibrium to be established, 0.1 ml of blood is found to have activity this. Calculate the volume of the blood, assuming no change in the activity of sample during circulatory equilibrium. So we are ignoring the radioactive decay. We are assuming that the time is very small. So the change in activity is negligible. Okay, so let's say volume of the blood is V. Okay, so activity 1.0, activity is given 1.0 into 10 to the power minus 7 curie, 1.7 curie, which is curie. So this is 1.0 into 10 to the power minus 7 into 3.7 into 10 to the power 10 disintegration per second, dps, disintegration per second. So that is 3.7 into 10 to the power 3. Okay, total volume is V plus 0.2 ml. This is total volume of the blood, because you have mixed we have injected 0.2 ml and original volume is V, so total volume is V plus 0.2 ml. Okay, so 0.10 ml gives 20 disintegration per minute, 20 disintegration per minute, that is 20 by 60 disintegration per second, then V plus 0.2 ml gives 1 by 3 into, 1 by 3 upon 1 by 0.1 into V plus 0.02 ml, 0.1 ml, so 0.02, no, it's 0.2 ml, just a minute, 0.2 ml gives 1 by 3 into 0.1, and this is 0.2 ml. So the total activity is V plus 0.2, okay, upon 0.3, and that activity is 3.7 into 10 to power 3. All right, so this is V plus 0.2. See, 0.3 into 3, 37. So 3 sevens are 21, 1, 2, 3 threes are 9 to 11. So 1, triple 1, triple 1. So 1.11 into 10 to power 3. That is 1110 ml. So V is approximately 1110 ml. So B is the correct option. Okay. So we have two springs. Block was initially at rest. Springs were unstressed. Sharp impulse is given. Then the period, maximum velocity, amplitude, ये सब हमें check करना है. तो सबसे पहले period देखें. तो K effective is K1 plus K2, which is 360 Newton per meter. So time period is 2 pi under root m by K effective. So that is 2 pi under root m. Mass is given 10 kg, so 10 by 360, that is 2 pi by 6, pi by 3 seconds, whereas in the option it is given pi by 6, so it is false. Now next is maximum velocity. So whatever be the velocity achieved by after getting impulse is the maximum velocity. So mv max, change in momentum, is impulse imparted. So Vmax is I by mass. I is given, impulse is given 50 and mass is 10 kg. So maximum velocity is 5 meter per second, whereas it is given 10 meter per second. So it is false. It is false. Now amplitude of oscillation. So amplitude of oscillation is Vmax is omega A, which is K effective upon m into A. So A is Vmax, which is 5, m is 10 upon 360. So this is 5 by 6, so 0.83 meters. So amplitude is 0.83 meters. So D is the correct option. Find the maximum value of B so that the system performs SHM. So initially system is in equilibrium. So spring force Kx naught is mg is acting in this direction, and there is deformation, compression in the spring, extension in the spring. Kx naught is acting in this direction. For torque balance in equilibrium, Kx naught into A is equal to mg into B. So Kx naught A equals mgb. Now the rod is deflected by a small angle theta. Small angle theta. So spring further gets stretched. Spring gets stretched by a theta. So spring force acting is K x naught plus a theta. This is spring force. Okay, and the rod gets tilted from horizontal by theta angle. Similarly, this B length, this also turns from vertical by theta angle. Now mg act vertically. Okay, mg acts vertically. So perpendicular distance of line of action of mg from the hinge is L plus b theta. So k x naught plus a theta, this is force, multiplied by perpendicular distance, which is approximately a. This torque is trying to pull the rod up, that this is restoring torque, and mg into L plus b theta, this is trying to move the rod down. Okay, so for if the rod is to oscillate, then the restoring torque should be greater than the clockwise torque. So this should be greater than 0 tau net. So we know kx naught a is mgb, so kx naught a is mgl, sorry, mgl, here I wrote b, it should be l, mgl. So kx naught a is mgl, so this cancel, this is ka square theta minus mgb theta should be greater than 0. So b should be less than ka square upon mg. So b maximum is ka square upon mg. A is the correct option. So this is a difficult question for NEET. Light of different frequencies, metallic surface, work function, there is the ratio of maximum speed. So v max is 2 k by m, k is half mv square, and this is 2 by m e minus phi. So v1 upon v2 is 2 by m e1 minus phi 1 upon e2 minus phi 2. So that is 2.5 1 1.0 minus 0.5 upon 2.5 minus 0.5. So this is 0.5 upon 2, which is 1 by 4. So this is 1:2. So maximum speed ratio is 1:2. The de Broglie wavelength of neutron in thermal equilibrium. So thermal equilibrium, the kinetic energy of neutrons is 3 by 2 kT. K is Boltzmann constant and capital T is absolute temperature. So this is kinetic energy. Now de Broglie wavelength lambda is h upon p, which is h upon root 2 kinetic energy E root 2 km, so root 2 em. So this is h upon root 2 3 by 2 ktm. All right, so h is 6.6 into 10 power minus 34 and 2 cancel, 3 k 1.38 into 10 power minus 23, this is k, t and m 1.67 into 10 to the power minus 27. All right, so 23, 27, 50. So this is 6.6 into 10 to the power minus 34 and 10 to the power minus 25. Now 3 into 1.38 into 1.67. So 1.67 into 3, that is 4.8 something, and 4.84 का square root 2.2 है, तो 4.8 something का square root we are taking approximately 2.2, and 1.38, see 1.44 is 1 under root of 1.44 is 1.2, so under root of 1.38 we are considering approximately 1.2. So 2.2 3s are, and 1.3 upon 1.2 2.5 into 10 to the power minus 9, that is 25 into 10 to the power minus 10, 10 to the power minus 10 to the power minus 10. So under root t as well, under root t. So the correct option is 25.2 upon under root t. So bit calculative. Raindrop of radius this has a terminal velocity is this. The viscous force. So viscous force is 6 pi r eta v. So all data, viscosity is given in CGS unit and force is also asked in CGS unit. So let's convert the entire data in CGS unit. So 6 into pi 3.14, radius 0.3 millimeter, so 0.03 centimeter. Eta is 18 into 10 to the power minus 5, and V is 1 meter per second, so 100 centimeter per second. So this is 6 3s are 18 into 3.14. 6 3s are 18 into 3.14 and into 18 into 10 to the power minus 5. Okay, so 18 18 324, 18 18 324, and 324 into 3.14 14 into 10 to the power minus 5. So this is around 1000. This is around 1000. So 101.73 into 10 to the power minus 4. So 101.73 into 10 to the power minus 4 dyne. This is the correct option. Two metal wires P and Q of same length material are stretched by the same load. Their masses are in the ratio 1 is to m1 is to m2, the ratio of elongation. See, we are not given their cross-sectional area. Their masses are given. So mass is area into length into density. Now chain elongation is FL upon AY, which is FL square upon ALY, which is FL square density upon AL density Y. So this is FL square density upon mass Y. So both the wires are stretched by same load. So F is same, length is same, density is same, Young's model is same. So proportional to 1 upon M. So delta L1 upon delta L2 is M2 upon M1. So C is the correct option. The distance between an object and screen is 100 centimeter. A lens produces an image on the screen when placed at either of two positions 40 centimeter apart. So this question is from displacement method, wherein on the optical bench, screen is fixed and the object pin is fixed. Now for two positions of lens, one is this position and another this position, image gets formed on the screen. So the separation between these two positions is suppose L, and separation between object pin and screen is D. Then focal length from displacement method is L square minus D square upon 4D. So power is 4D upon L square minus D square. Okay, so 4D is actually focal length will be in centimeter. So let's place in focal length is in centimeter. Power के लिए हमें मीटर में चाहिए. So 4 diameter to capital D is 0.4 upon L. Sorry, capital D L square minus D square upon 4. फॉर्मूला में थोड़ा सा मिस्टेक हो गया है. F is D square minus L square upon 4D. So power is 4D upon D square minus L square. So 4D is 1 upon 1 minus L, which is 0.4, so 0.16. So 4 upon 0.84. So this is approximately 100 upon 21. So this is 5 diopter. So B is the correct option. Displacement method सीखना है यदि आपने नहीं पढ़ा तो. A biconvex lens of focal length F forms a circular image of radius R of the sun in the focal plane. Then which option is correct? Okay, so magnification M is V, which is radius of the image, upon U. M is H2 upon H1. Sorry, M is H2 upon H1, which is equal to V upon U. So H2 is radius of the image, which is small r. H1 is radius of the sun, which is capital R. Okay, and V, image gets formed at focus, and U is the distance of lens from the sun. So small r is F capital R upon U. Now capital R and U are fixed, so proportional to small f. So area, which is pi r square, is proportional to F square. So B is the correct option. This H-shaped rod is released from horizontal orientation. So first let's calculate the moment of inertia. So this is H shape. So 1, 2, 3. So moment of inertia of first rod is 0 because it is along the axis only. For second rod it is ml square by 3, and for third rod it is ml square. So the total moment of inertia is 4 by 3 ml square. Okay, now when it comes into vertical orientation, the center of mass of rod 2 moves down by L by 2, and center of mass of rod 3 moves down by L. So loss in potential energy is equal to gain in kinetic energy. So center of mass of rod 2 moves by L by 2 downward. So mg L by 2 for rod 2, and for rod 3 mg L is equal to gain in kinetic energy half I, which is 4 by 3 ml square into omega square. So this is 3 mg L by 2 is equal to ml square omega square by 6. 4 just a minute, 2 by 3 ml square omega square by 6. So omega is 9g by 4l under root, which is 3 by 2 g by l under root. So C is the correct option. So it's a difficult question for NEET. Force of friction when the force F is applied tangentially on the rim and it rolls on rough surface. Okay, so let's say frictional force acts in this direction. So net force capital F minus small f is equal to ma. Net torque about center of mass, which is capital F r plus small f r, is equal to I into alpha, which is a by r for pure rolling. So when we solve it for friction, 2f barabar 0, friction is 0. So no friction acts on the ring. A PN junction in series with this in forward bias resistance is this, the forward bias current. So I is V upon capital R plus R diode. So that is 50 volt upon 5000 plus 50. That is 50 upon 5050. That is 1 upon 101 ampere, which is 1000 upon 101 milliampere. So this is 9.9 milliampere. 38. Truth table we can calculate. Steel wire of cross-sectional area A is heated by this and is stretched by tying its end rigidly. The change in tension when the temperature falls from 50 to 30. So this is thermal stress produced. So change in length is change in length due to the extra tension produced, that is delta F L upon AY, plus change in length due to cooling, which is L alpha delta T, and the total change in length is 0 since it is rigidly fixed. So change in tension delta F is minus AY alpha delta T. Now A is, see, this cross-sectional area should be 2 millimeter square. Okay, so minus 2 into 10 to power minus 6 y, which is 2 into 10 to power 11, alpha 1.1 into 10 to power minus 5, and delta T minus 20. All right, so 2 2s are 4, 2s are 8, 80, 88, and minus minus plus, so 88 Newton. So increase in tension is 88 Newton. Select dimensions of formula B square by 2 mu naught. So this is energy density, B square by 2 mu naught. This is dimensionally energy upon volume, which is ml2 T minus 2 upon L cube. So that is ml minus 1 T minus 2, ml minus 1 T minus 2. So D is the correct option. If theta is the polarizing angle for two optical media whose critical angles are this, so suppose rays, when ray is moving from medium 1 to medium 2, tan theta, polarizing angle tan theta is n of 2 relative to 1, which is n2 upon n1. Okay, now sin theta 1, sin theta, sin c1 upon sin c2 is 1 upon n1 by 1 upon n2, which is n2 by n1. So we can write tan theta polarization is n2 by n1, which is sin c1 upon sin c2. So tan theta is sin c1 upon sin c2. C is the correct option. At the first minimum adjacent to the central maximum of single slit diffraction pattern, the phase difference between the Huygens wavelet. So since it is a minima, so phase difference should be odd multiple of pi, and for first minimum this should be pi radian. So B is the correct option. An object of specific gravity rho is hung from a thin steel wire. The fundamental frequency for steel wire is this. The object is immersed in water. So previously tension in the wire was mg, and when it is immersed in water, half submerged, so tension will be mg minus buoyancy. Now buoyancy is volume submerged, which is v by 2 into rho of water into g. Now mg, volume submerged, is volume of the body is m upon rho b by 2 rho wg. So now the tension is mg 1 minus rho w by 2 rho b. Okay, so now frequency is proportional to under root f. So f2 upon f1 is capital F2 upon capital F1 under root. So that is mg 1 minus 1 by 2 rho upon mg. So that is F2 is 300 into 2 rho minus 1 upon 2 rho. So D is the correct option. Two waves of wavelength this and this produces 10 beats in 3 seconds. So beat frequency is 10 beats in 3 seconds. So 10 by 3 is beat frequency. So F1 minus F2 is beat frequency. Let's say wave speed is V. So V upon lambda is frequency. So V upon 1.00 minus V upon 1.01 is equal to 10 by 3. So that is 0.01 V upon 1.01 is equal to 10 by 3. So V is 10 into 101 upon 3, that is 1010 by 3. So 336.6 is the correct option. A uniform chain of mass length capital L is kept on a table such that small l hangs freely from the edge of the table. The total mass of the chain is capital M. The work done in pulling the entire chain on the table. So small l length is hanging from the table. Okay, this is small l. Its center of mass is at small l by 2. So work done is equal to increase in potential energy. So let's say mass of the hanging portion is small m. So small m g and center of mass raises by small l by 2. So small m g small l by 2. Now mass of the hanging portion, total mass of the chain upon total length, mass per unit length into small l. This is mass of the hanging portion into g into small l by 2. So now mass of the chain is 4 kg, g is 10, L square is 0.36 upon length, which is 2 into 2. So this is 3.6 joule. सो गाइज जो भी अपने इंपॉर्टेंट कॉन्सेप्ट सीखे हैं, जैसे डिस्प्लेसमेंट मेथड यदि आपने नहीं पढ़ा है तो उसको देखना है. कुछ क्वेश्चंस एक्चुअली डिफिकल्ट थे जो कि थोड़े कैलकुलेटिव थे, तो यदि हम फर्स्ट गो में उनको छोड़ देते हैं तो नो हार्म, सेकंड गो में वापस से हम लोग उनको ट्राई कर सकते हैं यदि टाइम बचता है तो. अदरवाइज मोस्टली उन क्वेश्चंस में डिफिकल्टी रहेगी, तो अपने छोड़ा है तो कोई नुकसान नहीं किया है. सो दिस इज़ अ गुड पेपर. ओके, हमें यहाँ से बहुत सारी चीज़ें सीख